Let's welcome Thomas Li, co-founder and CTO of VI-grade's new partner in the ADAS world, Chassis Autonomy, and Johnny Engström, CEO of CAE Value. Thomas will provide an overview of their patent-pending steer-by-wire actuator and discuss the critical importance of their strategic partnership with VI-grade and CAE Value to accelerate product development towards mass production for the next generation of highly automated, fully autonomous vehicles.
Okay, before I hand over to Thomas and Johnny, let me just give you a little bit of background of this presentation. I would say 99% of the time we talk about ADAS and autonomous vehicle. The discussion is about sensors, how sensors perceive the reality, how the algorithms are going to drive the car, how the passengers are reacting to those algorithms. And I would say most of us, at least me, often forget that also the chassis and the vehicle is going to a major transformation because of ADAS and especially because of the autonomy. And so this is a reason why, probably you can just, yeah, exactly. This is a reason why when I met this company, Chassis Autonomy, I immediately thought it was a good idea for VI-grade and also for our Nordic partner, CAE Value, to have a partnership with them. They are actually changing the way chassis will be driven, developing a new type of steering systems. And I immediately thought it was a great idea, as I say, to make a partnership and to work together in order to change also the way this kind of system can be developed, but also how this kind of system can be demoed to potential customers using simulation tool and using hardware-in-the-loop tools and the driving simulator. So we have signed a partnership with Chassis Autonomy and CAE Value, where I see a lot of synergies, really to change the way these systems are developed and demonstrated to potential customers. So I let you move forward with your presentation. Yeah. Thanks.
Great, thanks Guido. So we'll run through an introduction on Chassis Autonomy, where we've come from in a short period of 18 months since we incorporated, where we are now, and our vision, where we're going, and how we can even start to think that we can challenge the big legacy tier ones, the Bosches, the Contis, the ZFs. I'll hand over to Johnny. He'll give you a little bit about CAE Value, the expertise, the competence, and why working with CAE Value. Chassis Autonomy VI-grade is just such a natural partnership. I'll then go a little into Chassis Autonomy, the technology, the fail operational steering systems that we're developing. And then we'll focus a little bit on the development process, the zero prototypes, and that's why we're all here to really push through the simulation. So a little bit on Chassis Autonomy. We're a deep technology startup, headquartered in Trollhättan, Sweden, with a division in London in the UK. We span out of a Swedish OEM 18 months ago, but actually our history and the technology that we're developing, that started in 2018. So in 2018, we were working for the Swedish OEM. We were tasked with developing or finding a solution for steering systems and braking systems, specifically for that autonomous vehicle you can see there. After a 3-month investigation discussing with the big legacy tier ones, it was very clear they either weren't willing to or were unable to support us with our mission. So we developed a new division within the OEM, and we started developing steer-by-wire and brake-by-wire specifically for autonomous vehicles. 2.5 years later, we achieved proof of concept with that steering system, fail operational steering system that's equipped to that test vehicle there, front and rear axle, and until quite recently that was still being evaluated around a test track up in North Sweden. We span off specifically that technology. We're an independent company. Really the vision is to enable autonomous mobility through the provision of fail operational actuation systems. We've had significant traction in the short period that we've been operating, significant government grants from the European Union, the UK, significant financial investment from private investors. We've got key strategic partnerships, is the one that we're talking about today. And again, that's significant traction, which means now that we're not just focusing on level 4, but we've got customers for level 3 applications. So we're developing and deploying the road wheel actuator with a hand wheel actuator for human-driven applications. That's something we didn't envisage when we spun off the company. But again, such is the traction, the technologies that we've got, there's demand, and we intend to fill that. So our original tagline was enabling true autonomous mobility, but now it's enabling true automated mobility because we're also looking into highly automated level 3 applications. So that's a little bit on chassis autonomy. I'll hand over to Johnny. He'll tell you a little about CAE, and then we'll move on to steer-by-wire.
Thank you, Tom. So, hello everybody. In fact, I would like to start with a small story. Many years ago, 2005, we founded our company based on the vision to help our customers to extract as much value out of simulation as possible. So our customers were typically Adams users. I myself have used Adams since 1992. So we have a lot of Adams activities. We started with that in 2005. Then over the years, we found that our customers kept struggling with a couple of things. One was the fact that vehicle subjective experience did not always go hand in hand with the objective numbers from simulation. So that was a challenge. The other challenge was the conflict between different attributes, like vehicle handling would often go in conflict with vehicle NVH and durability and stuff like that. So lots of challenges, but then over time, 2 enabling technologies really came to light. One was the driving simulators by VI-grade. The other one was optimization technology, which is now sold by Siemens. We are partnering with Siemens as distributor for HiL's MDO and AIM-Sim, and of course with VI-grade for driving simulators and the VI-grade technology. We also partner with Stackpole Engineering for tire measurements in the cases we do services for vehicle development. And obviously chassis autonomy, it's really exciting. We have a very strong technical team. We're about 20 people in the company. Most of us are engineers and simulation CAE engineers. So we have, over the time, we built a lot of experience doing 2 things really well. The first one is taking optimization and making it actually deliver in vehicle programs. So we took it from being mostly research activities to something you do on a daily basis. The other thing we do there is that we help our customers put that into actual work and automate their CAE processes. The second thing we do, which we claim really well, is to be able to model any vehicle in great detail according to what is needed in each phase of the vehicle program. So we do vehicle dynamics, NVH, durability, motion control, energy management, and stuff like that. And of course, we developed some in-house tools over the years to make our process more efficient. Over to you, Tom.
Thanks, Johnny. So a little bit about the technology. When we remove the mechanical connection, either from the steering column or the brake pedal, we need to make sure the system's functionally safe. This has been talked about for the last 20 years. Technology is slowly getting there, but there's still struggles from the legacy tier 1s. But ultimately, our challenge is to develop the world's most safe actuation system, braking and steering. Our focus currently is on steering. So it's really underpinning the design, the concept by functional safety. To do that, we've assembled a world-class team. We've got the headquarters in Sweden, we've got an office in London, and we've actually got other engineers across Europe. So where we can't get the talent in our local division areas, we'll go elsewhere to make sure that we can get the best people in the world. So that's the world-class engineering team that we've got. And then when we start to actually look at the design, and because we're not a legacy supplier, we don't have manufacturing facilities across the world, we don't have to carry over existing technology, we can design from the ground up. So we can have a functionally safe electronics and software concept, and that's exactly what we've got. But when we start to look into the mechanical design, again, we design from the ground up. So we eliminate conventional concepts, we eliminate the established parallel axis drive, which has got a belt drive, a single point fault of failure, which is really catastrophic for a by-wire system. We also look into the concept, and again, for a steer-by-wire system that doesn't need a mechanical connection by definition, why do we want to carry over a 16th century technology such as the rack and pinion? Again, we delete that. What we end up with is a very robust design, mechanically robust, functionally safe in terms of electronics and software, and a system that's specifically designed for use in the by-wire applications. Added to that, the sensor concept. So the design, again, we've got an advanced sensor concept and control strategy. That makes sure that we have plausibility, redundancy. Most events that we have a system fault, we revert to an alternative operating mode. We maintain steering functionality, steering availability. Everything that we've designed in the concept and the product, we've got 10 patents pending. If you ask me tomorrow, that'll be 13. So again, we're pushing the boundaries, we're creating new technology, there's clear white space around what we're doing. Moving to level 3, so we've developed a functionally safe product on the electronics, the software, the mechanical design is robust. The next critical challenge really, I think, as we all know, is that steering feel. How do we make sure that we translate the road feel into the road wheel actuator, through the wires up to the hand wheel actuator? And that's the biggest challenge as we move into level 3. And that's really where the partnership with Johnny, CAE Value and VI-grade really helps us to accelerate the development through the use of hardware and the loop simulators to really advance the development of the system, the algorithms, the software before we even need to manufacture a prototype, put that on a vehicle. That's really advances time to market, reduces cost. It's fundamental to how we need to develop products, and that's pretty much why everyone here today is here, because of the zero prototype concept, and we're fully bought into that to develop the product. Level 4, a little bit different. We've got the road wheel actuator. We don't need to worry about steering attributes. They're out the window. And the same case with abuse cases. So the human driver, that 1%, we don't need to worry about that. So we have a different design case, a different duty cycle, different road loads potentially. And we're also working with, most cases, pretty new startups, well-funded startups, lesser well-funded startups, companies that potentially don't have the road load data, the design data to feed into requirements to allow us to optimize the system. So again, through simulation, we can capture that road load data from ODDs, we can define duty cycles, we can optimize the system, make sure it's designed specifically for that application. And now over to Johnny, he'll talk a little bit about the digital twin and really how we're kind of crossing the divide between the hardware and the loop and the software.
Thank you, Tom. So I'd like to say a few words about what we call a digital twin of the steering rig. So we have developed this model in Adams to be able to very, very precisely predict which will be the controller inputs and output signals and how that means for what that means for the setup of the actual test rig. And then, of course, we can look at how do we optimize the feedback torque, how do we take into account the excitation coming from the wheels, from the tire model, and overall system dynamics. So we can use this model to prepare for when you put the human in the loop, in the rig, very accurately. So we save time simply in the development by doing this. And the other thing we can do with this type of model is to, before running the actual physical durability verification, we can look at how should this duty cycle look like and what kind of excitation should we use in order to minimize the physical testing time, which is needed for verification purposes. So now I would like to talk a little bit about the challenges that Chassis Autonomy will see as a supplier. There are multiple different parts of this steering actuator that need to work together. It needs to be durable enough. The housing needs to be able to take shock loads and fatigue loads. Same thing goes with this actual steering, what you call it, the actuator itself, and all the internal components. And on top of that, you have a mechatronic system which needs to function properly and give enough performance, including the electric motor performance. So it's a lot of different things that need to fulfill multiple targets simultaneously, because there's no time to look at each individual component sequentially. So in order to overcome this, we're putting into place, helping Chassis Autonomy to put into place the right tools, the right methods, and kind of prepare all these different models for a subsequent multi-objective design optimization, which we know will happen. So for that, for example, we have Adams models provided by Hexagon. We have VI car models that will be used both offline and online in the steering rig. So there's a lot of things that will work together. And of course, once we start running the virtual multiple domain optimization, we use HIL's MDO for that, clearly. I think with that, I would like to hand over back to Tom.
Yeah, so I think just to summarize, this is a key partnership for all three companies. We will have a hardware-in-the-loop rig up and running by the end of the year, hopefully earlier. And really that's focused on developing these rapid simulation cycles, focused on zero prototypes. That's what we need to do. That's how we accelerate development and ultimately bring steer-by-wire to highly automated level 3 and fully automated vehicles. As we move through that and execute that, then we start to focus on brake-by-wire as well. So thank you for listening, and if you've got any questions, please fire away.